Section 5.8 Applications of Trigonometric Functions. Solving a right triangle means finding the lengths of its sides and the measurements of its angles. We typically use uppercase A, B, and C for the angles, with C being the right angle, and lowercase a, b, and c for the sides. Note that we have lowercase side A across from angle A, side B across from angle B, and side C, the hypotenuse, is across from the right angle. When solving a right triangle, we'll use sine, cosine, and tangent functions, mostly because they have buttons on the calculator. Example 1. Let angle A be 62.7 degrees and side A be 8.4. Solve the right triangle, rounding lengths to 2 decimal places. For our solution, we'll begin by putting the labels in of the sides and angles they already told us. We already know angle C is a right angle, so we don't have to solve for that. We need to find side B, side C, and angle B. It's probably best to start with angle B because the two acute angles of a right triangle always add to 90. So A plus B equals 90 degrees. B equals 90 minus A. Since A is 62.7 degrees, B is 27.3 degrees. So we can put that label in. To solve for the sides, we need our right triangle trig definitions. One memory device was some old horse caught another horse taking oats away. We have options over which side we find next and which trig definition we use, but one option is to use the tangent function to find side B. We know that angle B is 27.3 degrees. The side we're looking for is opposite that angle, and 8.4 is adjacent to that angle. So we can put tangent at 27.3 degrees equals B over 8.4. If we put the tangent over 1, we can cross multiply. So B equals 8.4 times the tangent of 27.3 degrees. On our calculator, we can get 4.34. We then label that. Finally, we need to find side C. We can use the sine function because it involves the hypotenuse, and the sine of A because we know that A is 62.7 degrees. That equals the side opposite A, which is 8.4, over the hypotenuse of C. Next, we'll cross multiply, so we can think of the sine as being over 1. When we cross multiply, it's usually most convenient to put the cross product that involves the variable on the left, and that equals the cross product of 1 times 8.4 on the right. We can get C by itself by dividing both sides by the sine of 62.7 degrees, which is approximately 9.45, and that's the final value that we needed to find. Here's a summary of the values that we found. This example is an application problem. From a point on level ground 80 feet from the base of a tower, the angle of elevation is 85.4 degrees. We want to approximate the height of the tower to the nearest foot. So we can make a sketch of the tower and label its height h. It says that the point is 80 feet away and that the angle of elevation is 85.4 degrees. Because we know the side that's adjacent to this angle and we're looking for the side that is opposite this angle, we'll use the tangent function. So the tangent of 85.4 degrees equals h over 80. Next we want to cross multiply, so we'll put the tangent over 1. Then we'll find the cross product that involves the variable so that it goes on the left, and on the right we'll put the other cross product. We can use our calculator to approximate this value. The height of the tower is approximately 994 feet. A guy wire that is 13.8 yards long is attached to a pole 6.7 yards up. We want to find the angle to the nearest tenth of a degree that the wire makes with the ground. We can draw the pole in the ground, and that makes a right angle. The wire is attached from the pole to the ground, and it's 13.8 yards long, and is attached at a height of 6.7 yards. We're looking for the angle that the wire makes with the ground, so we can call that angle A. From A's perspective, we know it's opposite, and we know the hypotenuse. So we're going to use the sine function because we know the opposite is 6.7, and the hypotenuse is 13.8. Since the sine of A equals this fraction, then angle A equals the inverse sine of this fraction. And we can use our calculator to find that the wire makes an angle of approximately 29.0 degrees with the ground.